All right, analyzing a rational function, part 2. Your professor gives you this function, g of x is equal to x squared minus 1 over x, and asks you to analyze this function. And as we analyze this function, we're going to look for some specific things, and your professor would expect you to know where the vertical asymptotes are, remembering that a vertical asymptote is a line that a function approaches but can't get through. It's a vertical line. And the way you would find that is you would take the denominator and you would set that equal to 0 and solve. So here we have x is equal to 0. Solve x is equal to 0 when x is equal to 0. Therefore, this is our vertical asymptote, and it also tells us our domain, and our domain is all x such that x does not equal 0. The next thing we're going to look for is horizontal asymptotes, and this function here actually doesn't have a horizontal asymptote. It has something called an oblique. And the way that we find an oblique asymptote is by looking for this pattern. So I'm looking for the degree of the polynomial in the numerator, and the degree of the polynomial here is 2. The degree of the polynomial in the denominator is 1. And because the degree of the polynomial on the top is higher than the degree of the polynomial on the bottom, we have to do some division. So first thing I'm going to say to my professor is that I know that we're going to get an oblique asymptote. And we're going to take a look on our TI at what that actually would look like. But an oblique asymptote, so what we're going to do is we're going to do some division. We're going to take x squared minus 1 divided by x. When we do that, we're going to get x here. X times x is x squared minus 0, right? I'm going to subtract this out the way you would do division, and we're going to get remainder 1. Therefore, this function simplifies to x minus 1 over x. And hopefully what you can see here is when we're talking about asymptotic behavior for an oblique or a horizontal, we're talking about end behavior. So hopefully we can agree, just looking at this piece right here, at the remainder here, when we're looking at this piece right here, hopefully we can agree that as x gets really, really big, well, 1 over a really, really big number is somewhere near 0. So we're going to say that our oblique asymptote is y is equal to x. All right? From there, what I would like to know is, what your professor is going to want to know is, what was our function's name? G of x? Does g of x intersect the oblique asymptote? That's a good question. So all we're going to do is set these things equal to each other. So we're going to say, does x squared minus 1 over x ever equal x? Remember, this x right here is this x, because this is the equation of our oblique. And then look, we're going to use means extremes theorem. We're going to just cross multiply here, and it becomes really clear really quickly that we're going to get here x squared over 1. We get x squared minus 1 is equal to x squared. Well, that's not true, is it? And if we just did some simple algebra here, we added negative x squared to both sides, we would get negative 1 equals 0. No. So they don't intersect, right? There's no intersection between these two. The other thing we could ask ourselves is, does our function have zeros, right? So the professor asked us for the zeros. So we could find the zeros of our function in our analysis. We take the denominator, x squared minus 1, set that equal to 0, and hopefully you can see that we would get that x is equal to plus or minus 1. So, right, so this function does pass through, right? Does pass through here and here. Let's take a look at what we have now. Let's go to our calculator to take a really quick peek. So here is that function. You said that the function passes through the x-axis at negative 1 and 1, and there's that, right? We said that this function has a vertical asymptote of x is equal to 0, and that's right there. And we can see that as x approaches 0, it also approaches the horizontal. It also approaches the y-axis. It does that here and here, doesn't it? So that's what we thought. We also said that we think we have an oblique. So I'm going to go back and graph that, and we said that we think the oblique is that y is equal to x. And there's that. And you can see that that's in behavior, and as x becomes enormously large, I'm moving this way, but just following my graph, that it gets closer and closer and closer to the oblique. And we prove that it never touches the oblique. So even though the pixelation of this computer makes it look like they do touch, they never touch. Look, you guys, I hope this was really helpful. The analysis of rational functions is kind of weird, but you have to look for some specific parts. Remember that you're going to look for vertical asymptotes in the domain. You're going to look for horizontal or oblique asymptotes. You're not going to have both. You're going to have one or the other. And then you're going to ask yourself the question, does my function intersect the horizontal asymptote? And you could also look for zeros of the function the way that we did. All right? Look, I hope this was really helpful. If you have any questions or comments, please let me hear from you. And if you haven't already subscribed, please do. Thanks. Appreciate it.